So we will continue with problems on gears. We have two external spar gears to be mounted 5.25 inch apart and have a gear ratio, which is the velocity ratio equals to 1/6. Find the data about the number of teeth of the gear and pinion, the diametral pitch, and the diameters of pitch circles for the two mentioned gears. Neither gear is to have fewer than 15 teeth, and if omega equals to 1000 RPM, find big omega. Now, in this problem, they gave us some constraints. So we need to do a certain design. First, we know that the set is external. So we have two external gears, and the center between the distance is imposed. So the first equation that we can write is that the distance between our centers, C, is given to be 5.25 inch. And we know that, so here just it's 5.25. And we know that to get the relation between summation of pitch diameters, all we have to do is to say that C represents the radius of the gear plus the radius of the pinion, okay? So it's equal to the diameter of the pitch circle. So here we always, when we talk about center between two gears, okay, we talk about radii of pitch circles, okay? So we have RP plus of the gear plus RP of the pinion, okay, equals to D of the pitch circle plus D of the diameter of the pitch circle of the pinion, okay, over 2. Sometimes to avoid confusion between symbols, okay, they consider that when we talk about diametral pitch, we can symbol it by PD, okay, and then when we talk about the diameter of the pitch circles, we take big D and small d. Okay, so you can use whatever you want, just indicate what do you mean by each variable. Here you can directly understand that this is the diameter of the pitch circle of the gear, and this is the diameter of the pitch circle of the pinion, and this is the diametral pitch value, and these are the number of teeth for your gears. Big T is for the gear, small t is for the pinion. So the first equation we can write now, since we know the distance between the centers, we can write that the pitch radius, as we said, of the gear plus the pitch radius of the pinion equal to 5.25. So we deduce that the diameter of the pitch circle of the gear plus the diameter of the pitch circle of the pinion over 2 is equal to 5.25. So D plus, here there is a small error, I will fix it. So this is 5.25. Okay, so you can deduce then big D plus small d equals to 2 times 5.25 equals to 10.5 inch. So this is our first equation, this is equation number 1. Okay, now we'll move to other relations from the given. From the given, they told us that the gear ratio or velocity ratio is to be equal to 1/6. So since this ratio is given, we know that the gear ratio or the velocity ratio will give us several information, because knowing that here big omega, this symbol is for the angular velocity of the gear, over small omega is the angular velocity of the pinion. Okay, This is equal to 1/6. And we know that the ratio of angular velocities is inversely proportional to the ratio of diameters, okay, and the radius and number of t's. So you can directly say that big omega over small omega is equal to small d over big D. And you have also that is equal to small t over big T. Okay, and now from here you can find a second relation between the diameters of your pitch circles. So big D equals to 6 times small d. So this is equation number 2. Okay, now after doing this, we can move to the equation of solving 2 equations with 2 unknowns. So by solving these 2 equations with 2 unknowns, we can get what is the pitch diameter of the gear and what is the pitch diameter of the pinion. Now, once I'm done with this step, I continue and I look at my conditions. I have another condition that neither gear is to have fewer than 15 T's. So I have a constraint on the number of T's. The minimum number of T's is 15. Of course, the number of T's of the pinion is always smaller than the number of T's for the gear. This is why in this case, okay, we'll use that small t. We'll start by the first possibility. Okay, so we'll set small t, which is the number of T's of the pinion, equal to the minimum, because in general, we try to have smaller dimensions if possible. Okay, so for t equal to 15, and knowing the relation between the number of T's of the pinion and the number of T's of the gear, you can get the value of big T. So big T is 6 times 15 equals to 90 T's. Now, whenever we determined the number of T's for our pinion and gear, we can deduce the diametral pitch. In the course material, we symbol it by dp. Okay, here we use the symbol pd. It doesn't matter. Okay, so here, to avoid any confusion between the pitch diameter and the diametral pitch, they used PD for the diametral pitch as symbol, and they didn't put any subscript. So it's better than to, because in the course material, we use DP for the diametral pitch and D for the pitch diameter. Okay, so just so you should know this, the way of representation. You can have this representation, you can have this one, okay, to avoid any confusion after. So now, once we determine the number of T's, okay, we can make sure that the diametral pitch, of course, is the same for both, because we said whenever we have 2 gears in mesh, they should have as condition same diametral pitch. So you can calculate the diametral pitch or from the gear or from the pinion. You'll get exactly the same result, because PD is supposed to be equal to the number of T's of your gear over the diameter of the pitch circle of the gear, and it's equal also to the ratio of the number of T's of the pinion over the diameter of the pitch circle of the pinion. So in both cases here, you will get 10 T's per inch, because here, if you do it for the pinion, you have 15 over the pitch diameter of the pinion, which is 1.5. And if you do it for your gear, you have 90 over 9. So as expected, you get the same result for both. Okay, now, so we have determined until now a configuration satisfying, if you want, the conditions of the distance first, the distance between the centers that imposed on us the pitch diameters, and then we satisfied the condition of minimum number of teeth. We directly considered the minimum to have, if you want, a minimal size, but of course, this is not the only solution. You can take larger than 15, but one of the possibilities with a compact design, the most compact design will be to take the smallest possible number of teeth, which is 50. Now, they are also asking that if for this configuration, we need to impose an angular velocity for the pinion equal to 1000 RPM, what will be the angular velocity for the gear? So of course, this is simple. Since we know the ratio of angular velocities between the two, since we have the gear ratio, then we just set the conditions that the angular velocity of the gear is equal to the angular velocity of the pinion over 6, and then we can find the value of the angular velocity of the gear. Always the angular velocity of the gear will be smaller than the angular velocity of the pinion, because we have seen that the ratio of angular velocities is inversely proportional to the ratio of radii, and this is due to the non-slip condition. So you should have common velocity at the contact point. So V, which is equal to R omega, is the same for both. Okay, this is why the ratio of the radii is inversely proportional to the ratio of angular velocities. So this is a simple design problem. It's relatively simpler than the one before because here you had directly no decimal points. However, whenever you have decimal points in your calculations, this will make it more challenging. You should do several iterations until reaching the required solution. Let us move to another problem. We have a 6 diametral pitch, 20 degrees pressure angle, 19 tooth pinion is meshed with a 37 tooth gear. We want to find the gear ratio, the circular pitch, the base pitch, the pitch diameters, the pitch radii, the center distance, the addendum, dedendum, hole depths, clearance, outside diameters, and contact ratio of a gear set with the given parameters. So this problem, if you want, is a review of all characteristics of gears in mesh. So we'll go over the different steps of calculations. For this, you will see that it's a very typical procedure, because once you have the parameters of your gears, you can easily determine these parameters. Okay, just use formulas, you apply formulas. So let us start with the first part of the question. So first, we know the diametral pitch. We know so this is, here they call it PD, in the course we call it DP. So it's equivalent whenever you have P and D, so this is diametral pitch. And whenever you want to talk about the pitch diameter, you can just put it as D. Okay. Now, this is the number of teeth. The number of teeth in some books is called N, and in some books it's called T. So also be familiar with both ways, okay? Because you might find it in this way or in the other, okay? Now, we have that the pinion is meshed with a 37 tooth gear. So this is the number, this is big T, if you want, or big, sometimes they use big T, small t, and here for the pinions they use small t, for the big gears they use big T, or if you want also, you can use big N pinion and the big N gear, okay? This is another way also to have your presentations. Now, to start with, okay, knowing this, we can get all of other parameters, because if you remember, first, to get the gear ratio is equal to the ratio of the teeth number of the pinion on teeth number of the gear on the teeth number of the pinion, because this is equal also to if you want the diameter, the pitch diameter of the gear over the pitch diameter of the pinion. And also it's equal to the ratio of angular velocities. So omega pinion over omega gear. So whenever you have both angular velocities or both diameters or both number of teeth, you can determine the gear ratio and you can deduce a relation between the other parameters. Now, the second parameter here to determine is the circular pitch. The circular pitch that you can symbol by PC. If you want, let us go back to in the course material here. Okay, you have also different ways of naming, so you can refer back to it. So here we call it the circular pitch P. Here we call for the diametral pitch we use PD. Sometimes we use DP. So it depends on the book. Okay, it depends on the book you are using. Just be familiar with all of these. In general, of course, in the exam, we'll give you the same way as in the slides. Okay, to not confuse. But just for problems, because I'm trying to search for problems from different references. Okay, you will have sometimes difference in the way to name. Here, of course, as I told you, what you should, you are responsible mainly of this type of naming, because this will be given for you in the exam. But just to be able to do extra problems, you should know what are the different possibilities. Okay, so in general, we assign circular pitch by P, the diametral pitch by PD. If you see it as DP also, it can be used for diametral pitch. Now for addendum, dedendum, we use A and B. And for face widths, we use F. And here in this book, we use for the number of teeth, big N. Okay. So now, if we go back to our problem here, just for the circular pitch, instead of using just P, they consider a certain subscript for P. So P is equal to PC. Okay. Now, to calculate the circular pitch, we know that if we know the value of the diametral pitch, we can deduce P, because we have a relation that P, which is the radius of the circular pitch, times PD, which is the diametral pitch, is equal to pi. Okay, so we can simply say that the circular pitch P can be given by pi over PD. Okay, and now the second parameter is the base pitch. The base pitch, which we symbol by PB, okay, is can be calculated based on the value of the circular pitch, because we know that PB is equal to PC cosine phi. Okay, so all you have to do is to use your pressure angle. Knowing the value of your circular pitch, you can deduce the value of your base pitch, which is measured on the base circle using the following formula, which is PC times cosine phi. Now, also, okay, they want us to determine what are the values of the pitch diameters and pitch radii. Okay, so here we need to determine if you want small d and big D for the gear and for the pinion. And also we want to determine small r and big R. Or as I told you, you can use symbol subscripts. So you can use D gear, the pinion to know the difference between both. Yani, one way is to use capital letters for the gear, and one way is to just put a subscript. So when you put G subscript is for the gear, when you put P subscript, it's for the pinion. So here we already know the value of the diametral pitch, okay? And we know from definition that the diametral pitch is related to the diameters of to the diameter of your pitch circle, okay? So you can say here that small d, which is the diameter of your pitch circle for the pinion, is equal to the number of teeth for the pinion over the value of your diametral pitch, because we know that the diametral pitch PD is defined as the number of teeth for your gear, okay, over its diameter, okay, and the unit in general is inch minus 1. So since the value of the diametral pitch is provided for us, we can deduce pitch radius for both gear and pinion, okay? So for the pinion, you have D equal to 19/6, and for the gear, it's equal to 37/6, which is, so for both cases, we have same PD, but different values of M, okay? And now, once we determine the diametral, the pitch diameters, we can deduce the pitch radii by just dividing by 2, okay? Again, here, as I told you, you have several ways to present, okay? So, or you use the subscript P and G for pinion and gear, or you can use also small d and big D, okay? To avoid any confusion between DP and PD, okay? Now, concerning the nominal center distance, you know that the distance between centers is the summation of pitch radii. So all you have to do then is to do sum of RP plus RG to get the value of your center distance. And for the addendum and addendum values, so I remind you, once we have our tooth and we determine the pitch circle radius, we have the total height of our tooth is divided into 2 parts. This one, which is from the pitch circle to the top circle, and this is called the addendum. And we have from this the pitch circle to the bottom circle, which is called the addendum B. So, and these are function of the diametral pitch. You have their formulas in the course material. You have that A is 1/PD and B is 1.5/PD. So you can get the values of A and B. And the whole depth of your tooth is the summation of A plus B. So once you find A and B, you will be ready to get the whole depth HT, which is the sum of addendum and addendum. So HT is A plus B. We can find its value. Now, the clearance is the difference between the addendum and addendum lengths. So all you have to, if you remember, if we go back to the course material, when we talked about the clearance, as you can see here, this is the clearance. So it's the difference between, if you want, whenever your two gears are in mesh, you will have the top of the gear will be at a certain level, okay? The distance between the top of the meshing gear and your second gear, and if you want the root of your the bottom of your second gear, this distance is called clearance, okay? So if the gears and interaction, if it will hit the bottom, then the clearance will be 0, and this is not recommended in general. Okay, so to avoid any additional mechanical constraints, so the clearance will be the difference between, if you want, the top of the gear in a mesh and the bottom of the other gear. And then we say that the remaining distance is what we call the working distance. Okay, so because this is the one where you have interaction between the two gears. So in order to calculate the clearance value, okay, what we should do is just to apply the formula. So the clearance is simply the difference between the addendum and addendum values, and the if you want the penetration depth, then okay, or the working depth will be H minus C. Now, concerning the values of the outside diameters of each gear, so whenever we talk about the outside diameter, so we mean the diameter passing of the circle passing by the top of the gear. So this is your gear. Okay, we have we said that we have the pitch circle which will pass through the contact point between gears, and you have the top circle. This is what they are asking about. This is the outside diameter of each gear. So this is what we call addendum circle. Okay, so we have already that if we know the pitch radius and we add to it A, we get the radius of the top circle, of the outside circle. So since they are asking for the outside diameter for each gear, all we have to do is to add to the diameter of the pitch circle. Okay, we should add 2 times A, because for the radius, so the radius R of the outside circle is equal to the pitch radius, which is R, plus the value of the addendum, which is A. Okay, so whenever you want to have the diameters, you just multiply by 2. 2R will give you the diameter of the pitch circle, and adding it to A, you get the diameter of the outside circle. Okay, now for your you do this calculation for your pinion, you do this calculation for your gear, and then you can get the value of, for each, what is the value of the outside diameter. Now, they also asked to get the contact ratio. To remind you, the contact ratio is defined as following. So you can see it in this slide. Okay, the contact ratio by definition is the average number of teeth in contact at any instant. So it can give us an idea about what is the number of gear in contact at a certain instant. And the recommended value for it is between 1.4 and 1.5. And to calculate it, you need to determine 2 parameters, Z and PB. PB is the base pitch. So we already calculated PB in this example. We still have to calculate the length of contact path. The length of contact path is depending on several parameters. Here in this in the slides, we just refer to pinion and gear as 1 and 2. Okay, or you can use the subscript also P and G for them. And you can use what you want. Okay, so all you have to know, you should know the pitch radius. You should know for each, you should know for your if you want for your pitch and for your gear, for your pinion and for your gear, you should know the pitch radius. You should know the addendum value A. You should know the pressure angle. already all of these are calculated from previous tests. So you have for 1 and 2, and for the gear and for the pinion. Okay, and these two, if you sum them in one term, if you take sine phi into factor, you have minus sine phi times R1 plus R2. And you know that summation of radii of pitch circles will give you the distance between centers C, which also was already calculated in this problem. So you can replace these two terms by minus sine phi times C. Okay, so if we go now back to our problem here, we just have to replace numerically for the pinion and for the gears the values of the pitch radius, the values of A. The pressure angle, of course, is the same for both. And you have C is already calculated, so you can get the value of Z. We already also calculated the base pitch. Okay, so now we can just apply the formula to get the module. And as you can see here, the value is a little bit larger than the one that is recommended, so it's fine. It's recommended to have it between 1.4 and 1.5 is good, but it's fine if we have a certain margin, you can play with a certain interval. Okay. Now, this next question is there any interference between the gears? Okay, is there a possibility of interference between the gears? So whenever we want to know if there is interference or not between the gears, we should go to the table of interference in the course material. Okay, already to be able to determine the interference condition, we need to know an information about the value of the pressure angle and the number of T's for our pinion and gear. So as you can see here, I know that the pressure angle is 20 degrees. The number of T's for my pinion is 19, and for my gear is 37. So I go back to the table of the course material for interference. This is my interference table. Okay, this is my interference table. First, my first input is the pressure angle. Okay, so this is the pressure angle. And concerning the number of T's for my pinion is 19. And in this table, you can read for each number of pinion T's, what is the maximum number of gear T's. And as the number of pinion T's will increase, then you will have a larger range of possible number of gear T's without interference. And after 18, from this table, you can see that after 18, the maximum number is infinity. What do we mean by this? We mean that whatever is the number of gear T's, of course, it is higher than the number of T's in pinion because of the ratio. Okay, but whatever it is, will have no possibility of interference. Okay, and here you don't have to worry about possibility of interference if your number of pinion T's is larger than 18, and you can know the corresponding value of gear T's depending on your design. So here, for example, in this design, it's 37. Okay, but you can go up to infinity without interference. So whatever is your selection criteria, you are on the safe side for interference. No possibility of interference, okay, when you have the number of pinion T's higher than 18. So here you can say I am on the safe side, there is no interference. And so you can just say this, you can say from the table, okay, from the table for a pressure angle of 20 degrees and the number of T's larger than 18, which is the case in our problems, there is no interference. And you have here an illustration about this. So in this region, no interference. If, for example, the number of pinion teeth was 15, then you say that I can have a maximum number of gear teeth equal to 45. If I have a number above 45, then I will have interference. Okay, if I have a number below 45, then I am on the safe side. Now, finally, I asked you, if the center distance is increased 2%, what is the new pressure angle? In general, what I want you to know, when we manufacture a gear, we manufacture it, let's say, based on certain idea about how we want to do the assembly. And let's say, in general, we know we want to have a certain distance. It's given. But sometimes, because assembly errors, you might have sometimes some errors, some deviation from the required values. This is why one possibility is to have an increase in the center distance while you need to have another distance. Okay, so to know what will be the effect if we have a small assembly error, or if we have, let's say, if we change the center distance for a certain reason, it's increased by 2%. What will be the effect on the pressure angle? To be able to answer this question, we should understand, if you want, the concepts of base circle and the concepts of pitch circles. Okay, to remind you a little bit, so whenever we have a certain gear, okay, when you want to design a gear, you say that I want to have an involute teeth. Okay, and to have an involute teeth, it's geometrically determined from the base circle. So first, whenever you want to do a gear and put your teeth in involute form, you should determine for this gear what is my base circle value, which is we know how to here we have calculated, if you want, the value of the base pitch, and from the base pitch we can deduce the value of the diameter or radius of the base circle. Okay, so the base circle, so we already determined the value of PB. Okay, and we have a relation between PB and the diameter of our base circle, because they are related through the following relation, like the relation between diametral, if you want, diametral pitch and or if you want circular pitch and the value of diameter of the pitch, because you know that diametral pitch PD, okay, is equal to pi over P. Okay, and what is the circular pitch? What is the value of the circular pitch? The circular pitch P is equal to pi times D, which is the circumference of the pitch circle, over N. Okay, while for your diametral pitch, if you replace P by its value, you get the definition of the diametral pitch, which is N over D. Okay, in this problem we already calculated PB, the value of PB. PB stands for it's like, if you want, the definition of the circular pitch, but instead of using the diameter of the pitch radius, you will use the diameter of the base radius. So PB is equal to pi times dB, which is the diameter of the base circle, over N. Okay, so the idea is that when I determine for a certain application, the value of PB, I am determining a certain diameter for my base circle. Okay, and when I determine this diameter, how to do the construction of your teeth of your tooth in involute form. The idea is that when we developed the course material, we said that the normal to the involute curve should be tangent to the base circle. Okay, and because of if you want, the idea is that whenever we have in contact two involute and we draw the normal line, the normal line should be always tangent to the base circle. So in real case, how we manufacture it, we say that I have the value of the base circle, which is the radius, let's say. This is the radius of my base circle, and I want the involute, the teeth in reality, okay, will not stop here because you have a form like this, and you have your teeth like this, and then you have a certain shape after that will connect it to the bottom circle. There is a difference between the bottom circle and the base circle. So if I give you a certain graph, okay, you have that the involute profile will not start from the bottom. It will start from a certain level, which is the level of the base circle. And below it, you have another profile, okay? And this profile will depend on the design procedure. It will depend on the pressure angle you want. It will, and we have seen that you can do some cutting here also to avoid interference, etc. But the base circle is defined as, if you want, the start of the involute profile. And below it, you can have like a different profile until reaching this is your bottom circle. So this is your bottom circle. This is your base circle. Okay. And the involute geometry will start from this level. And we can see here how we can design it. The idea is that always the normal to the involute should be tangent to the base circle. And this will allow you, so if you consider a certain, what we call a string tangent to base circle and normal to involute, if you consider a certain number of points, okay, from these points you can draw the different tangent lines. And since the involute should be normal to these tangent lines, you can detect what is the shape of your involute. Okay, I am explaining this for you to understand that if I vary the center distance for a certain reason of error in assembly, the base circle will not change. What will change is the contact point between the two gears on the involute, because we have seen that the pitch circle radius is determined by the contact point between involutes, okay, of the two gears along the line of centers. So if you change the distance between centers, then the contact point location on the involute will change, but the base circle will remain as it is. This is why here they told us that the distance between centers is increased by 2%. We have already the previous distance. We can find the new one, okay? And therefore, we can say that the pitch radii will vary by the same amount, because the distance between center is the summation of pitch radii, okay, of the pinion and of the gear. So then what will change here is the pitch radii, not the base radii. So the base radius for each of our pinion and gear will remain the same because they are imposed by the geometry of the involute, which will not change for the two gears. But what will change is now the separation distance between the two gear center, which will lead to a different contact point and therefore a different contact angle. Okay, so a pressure angle. So here, going back to the given, okay, we have that the value, so if the center distance is increased from the nominal value due to assembly errors or any other factor, the effective pitch radii will change by the same percentage. However, the gear's base radii will remain the same. And if you want to get the new pressure angle, you know that your pressure angle is defined in this way. Cosine phi is equal to the base radius, okay, RB, over the pitch radius, RP. We have now RB will still the same value as before. So before we have already calculated RB, it is equal to RP cosine RP old if you want. So it's RP old cosine phi. So I will call them phi old and phi new to not confuse. So cosine phi new is equal to RP old times cosine phi old over RP new. Okay, and we said that RP new is increased 2% compared to RP old, like the center distance. So we can express RP new as RP old times 1.02. So RP new is equal to RP old times 1.02. And then I can simplify RP old and RP old and say that phi new is cosine minus 1 cosine 20 degrees, which is the old pressure angle, over 1.02. So this will lead a 2% change in center distance will lead to a certain variation of the pressure angle. We can see that an increase of 2% in this distance will lead to an increase of 2.89 degrees compared to 20 degrees. And if you want to calculate this, the percentage of increase, the percentage of increase of phi is equal to delta phi over phi old, which is equal to 2.89 over 20. Okay. And you can see that the percentage of variation for the pressure angle is relatively high compared to the one of the center distance. So if for a 2% variation in the center distance, the pressure angle varies by nearly above 10%. Okay. So this is why we should avoid any assembly errors, because it will affect the operation of our gear system. So this is for gears problems. We'll continue together next time with more details about the gears, how we put the gears in trains, and how we study their kinematics. Thank you.